operation of a MOSFET as VDS is increased. So when we consider this, we first consider that VGS is above VT, so that the channel is conducting, and we slowly increase VDS. We see that the depth of the channel changes. Now this is because the difference between the voltage at the gate and the substrate is keeps changing. The voltage between the source and the drain increases from 0 to VDS. Therefore, the difference between the gate voltage and the substrate and the voltage just below the gate varies from VGS to VGS minus VDS. Due to the difference in the voltage, the channel depth varies. It is highest near the source and lowest near the drain. When it reaches the point VGS minus when it reaches the point where VGS minus VDS is equal to VT, the channel pinches off, or basically there can be no more increase in current beyond this point. It saturates. Sort of like VT is the threshold limit, and you require VT for, and there's no VT here. And also you can think of it as number of electrons that can come from all sources, from the N substrate and from the whatever. You can't have any more electrons, and you can't have any more conduction than there already is. So therefore the current reaches a limit and it goes into the saturation region. That is once VGS minus VDS is greater than VT. So yeah, that's your saturation region. Okay, so then after that what happens is let's go here. So you can see clearly in the graph here what we saw before in the previous video is the linear portion. Then it slowly bends, and as we increase VDS beyond, the resistance also increases, and this is due to the bend in the channel depth, change in the channel depth, and finally it reaches saturation. That is when VDS is greater than VGS minus VT. Okay, and so this is called your triode region. This is called the saturation region. And then after that we see that VD equal to VG minus VT, and VD it varies for every case, as you can see. For every value of VGS there's a different value of VD a better understanding can be observed from this graph, this diagram. When VDS is equal to 0 and VGS is above VT, because obviously we need that for conduction, the channel depth is constant between source and drain. As VDS is increased, the depth of channel near drain slowly increases and reaches point 0 when VDS is equal to VGS minus VT. And that's it.